Welcome to JD's Prep. In this problem, we want to know, compared to the graph of f of x equals x squared, the graph of g of x equals x minus 2 squared plus 3 is the result of translating the graph of f of x in what way? We have four different options here, and we want to know what is it about our g of x that is causing us to translate or shift the graph of f of x equals x squared. For these translations, the things that are causing the graph to move are the numbers being added to or subtracted from the x and the overall square. Since the negative 2 is happening directly to the x on the inside of the square, then we can think that this is causing a translation in the x direction, which is left or right. Whereas the 3, which is on the outside of the square, this is happening after you apply the square. This is going to be affecting the y, or the output values, moving us up or down. So the 2 is going to be the distance that we move to the left or to the right, and the 3 is going to be the distance that we move up or down. The only part that remains is to know which direction we're moving. For the x direction, when we are adding or subtracting numbers on the inside, if we are subtracting, right, if we have a minus inside, that's telling us that we are going to move to the right. The reason for that is that we need a higher x value than before to get the same result. For instance, if I plug in x equals 0 to f of x, right, I would have 0 squared, which is 0. But if I plug into the x minus 2 squared and I want to get 0, I have to plug in x equals 2 to get the same end result. So I needed a higher x value than I would have originally with f of x to get the same result from the square. Needing a higher x value means your x's are moved further over to the right, which is the positive x direction. On the other hand, if I add on the inside with the x, that's going to move me to the left for the same sort of reason. If you add a number inside, then you can get away with a smaller x value than before to get the same result, and smaller x values are located to the left. Putting those two things together, the distance of 2 and the subtraction, meaning that you're moving to the right, that tells us that our graph is being translated 2 units to the right. On the other hand, the plus 3 on the outside, this is happening after the square is already done. So if we have a plus on the outside like we do here, that's going to take the output values and just increase them further, moving us up. Whereas if we have a minus on the outside, after we've computed the square, that's going to take the result and move them down by subtracting values. So putting that together, the plus 3 on the outside is telling us that we are moving 3 units up. So our graph of f of x is being moved 2 units to the right and 3 units up to give us the new graph of g of x, which is our selection number 3 right here.